so back to the basic scheme width of the road. So in this one again, this is our 3D rendering, a section of it. As I said, 11 feet width, 5 feet bicycle infrastructure, and approximately a 4.5 feet planting strip, 5-foot sidewalk, and 2-foot setback or easement to the building line. Our next design is the boulevard scheme, which is 63 feet wide. This scheme is you'll see the only difference really is that it has a median in the middle of it, and the same road width, same sidewalk width. Now this rendering shows foliage all the way along the median down the middle. However, these could be islands, so there could be breakpoints in the middle for turn lanes, of course. This is merely a conceptual drawing. All the other aspects of this are the same though. And our final scheme, which is the one we recommend, it's a boulevard with green stormwater infrastructure, and it's 70 feet wide. Designing the street out to this width allows the maximum flexibility in future considerations. Those considerations being this flex space here. So instead of just your standard 5-foot bike lane on either side, this is a full 8-foot width, which is standard for traditional or contemporary, streets, which allows for either a bike lane or parking depending upon what's needed. So if you build it out this wide to begin with, you have a lot more options down the road, no pun intended, with how you want to utilize the street infrastructure. This scheme in particular, as we said, has green stormwater infrastructure, so it's a stormwater infrastructure median down the middle and stormwater infrastructure planting along the side, which helps with easement of runoff, pollutants, and contaminants from the street, which is standard these days with more and more streets, particularly with extreme and inclement weather conditions, as we have more and more heavy downpours that overwhelm the stormwater infrastructure. These are the contemporary and natural sort of way to support the stormwater infrastructure in cities. This slide goes into a little bit more detail about what green stormwater infrastructure is. On the left here, the permeable pavement can be used in a number of locations. That can be used in parking strips, bike lanes. So if we go back one slide and we look at this bike lane could be a permeable, either permeable concrete, which absorbs water and lets it seep into the ground slower, or it could actually be pavers. These permeable pavers, as you can actually see from the shadow here, that's a car park there. So you can actually use this for parking. It's used in many cities all over the country for not just walking, but for parking as well. In the middle here is the green stormwater median, which again, as you can see, much better visualized here, allows for not just overflow of downpours and stormwater infrastructure, but creates a really nice feature, a central feature of a main street going through the property. So it's this is wider than 7 feet, but this would be approximate to what we would recommend. And then to the right, stormwater strips. It's a little less visible here, but this is a street over here, this is a sidewalk here. So this is essentially between the street and the sidewalk. This provides more overflow from the street, and this is an example of, you have sort of rocks and filtration in the middle, planting, and any number of elements. And again, it provides not just stormwater infrastructure drainage, but also really nice amenity for a more walkable, livable, sustainable streetscape.
And that last one is actually under the Aurora Bridge in the Seattle area, if you're familiar with
Right.
it at all. So it's
Right.
a local example of how this can be utilized.
Yes.
And with that, we will go, or Manny and I, will be discussing the street infrastructure cost comparisons for the basic boulevard and boulevard green stormwater infrastructure schemes. Thank you. To start, our cost estimates are derived from an Excel cost calculation sheet from Maple Valley engineer Bill Bullock. We used the template and included our numbers that we found from the lengths of the roads of the schemes, and that is how we got these cost estimates. I should mention that we estimated the total length of the road to be approximately 2,100 feet. For the basic, which is the cheapest option, construction cost subtotal was at $2,715,000. Contingencies was at $271,000. Design engineering at 10% was $299,000. Construction management at 8% was $239,000. And as you can see, we are assuming the right of way is $0 because the city of Maple Valley owns the property for this road. This brings the project total cost to be approximately $3,524,000, which makes the cost per linear foot an estimated $1,700. Next, we will be looking at the street infrastructure cost of the boulevard. The construction cost subtotal was at $2,849,000. Contingencies was at $285,000, and the way we derived the cost for the median was from a case study in Grand Rapids, Michigan, where they had a project called the Median Island Project. We picked this case study because it had similar weather conditions to Washington and adapted our numbers based on their cost comparisons, and this was the $597,000 was the estimated cost that we got. Design engineering at 10% was $313,000. Construction management at 8% was $251,000. And once again, we are assuming the right of way is $0. This brings the total project cost to be $4,295,000, making the estimated cost per linear foot $2,000.
And this is the cost breakdown for the boulevard with the green stormwater infrastructure. The subtotal cost was $2,943,000. The contingencies are $294,000. The design engineering at 10% is $324,000. The construction management at 8% is $259,000. Again, assuming the right-of-way is $0 because the city of Maple Valley owns the property. One of the features in green stormwater infrastructure is the permeable pavement, which we estimated to be $406,000. The stormwater median at 7 feet wide, we estimated to be at $916,000. And the biofiltration strips at both sides of the road, both each 4.5 feet wide, estimated to be $12,400. I should note that we got the cost estimates for the biofiltration strips, the permeable pavement, and the median, which includes green stormwater infrastructure, from an EPA website. We combined all the elements that goes into a stormwater median, and that's how we determine the cost estimate. So that brings the project total cost at $5,154,000.
Wait for Christoph.